We'll get started. Thanks for attending the session. Hope you guys have had a great Ignite conference, getting lots of knowledge. All right, so my name's Karan. I'm part of the high-performance computing team at Azure, and I work very closely with a lot of customers. And so today we're going to be talking about some large-scale applications and workloads that run in the cloud. And mostly I'm going to be talking about our new service, which is Azure Batch. We are in public preview currently. We released last year. We're going to go for general availability later this year, so look out for that. And so I'm also going to be talking about a few concepts around big compute, what that word means, what the word means in its context, in this context. When you're talking about a few customers that are running on top of Azure Batch, talk about a few of the other services that we offer, show you guys a couple of demos, and then we'll leave quite a bit of time at the end for Q&A. And then I want this to be sort of interactive, so after a few slides, I'll kind of fish out and see if anyone's got questions. So we'll get started. All right, so I just want to start with our mission statement. This is something that we sort of aim for and look at before we build a service on Azure. And we really want to take workloads out there, not just sort of true HPC workloads, but everything that's sort of compute and data intensive. And we really, really want to make it simple and super easy for you guys to then offload that to Azure. And so, that's what we really mean by big compute. That word is essentially a, combination of anything and everything that's big, just data intensive and or compute intensive. Anything that churns a lot of compute power is what we sort of refer to as big compute. And some of these workloads could include things like, media encoding, transcoding. 3D rendering is a pretty big one. It's used widely in media, entertainment, advertising, even architecture. Then we have image analysis and processing, software testing and execution, fluid dynamics. We have oil and gas workloads, which is a pretty big one. Then we have Monte Carlo simulations in financial industries. We have statistical analysis, Hadoop jobs. So there's a lot of stuff out there that can be sort of construed as big compute and can sort of take advantage of sort of the vast computing power in Azure. And so, why do we want to use this thing called big compute for Azure? Why do we want to use it on top of Azure? Well, let's look at the sort of current scenario and how people are using clusters. So mostly clusters are on-premise. They're probably Windows or Linux. They're probably configured and managed manually. And so, you're kind of limited by the amount of cores or clusters you have on-prem. So if you need to burst out, you have to go out and buy more hardware. And so that might not be possible for everybody. So Azure really opens up, this broad variety of customers that can then, actually use Azure for offloading their capacity. They don't have to go out buy more infrastructure. They let us essentially manage that. And this helps them sort of, small organizations compete with the big guys, right? So they don't have capital to actually go out and buy more cores or more hardware. They can then compete with the bigger guys because they're able to do things that weren't previously possible. And then, there's also the thing about paying for what you use. So, you only pay for the amount of time that you're actually using the compute. So if you have a workload that you need to run, you only pay for the time when that VM spins up, executes your work, and then spins back down. So you're only paying for the amount of work that you're using on Azure. Whereas, if you have on-prem infrastructure, it's just sitting there, even if it's not running any workloads, it's still costing you money. You're actually going to have to maintain that, update it, make sure it's running properly. So that's a lot of overhead. And so the service is, enterprise ready. You have massively, hyperscale type of compute that's available to you at a click of a button. We also think about things like security and compliance. So if you have things like encryption, HTTPS on your mind, we can help with that. We also support sort of large and small scale deployments. So you can go from anywhere from tens, hundreds of machines and cores to 10,000, 100,000 cores. So we kind of support all that scale and really deliver that. And then we have a global network of data centers. So if your customers are located anywhere in the world, we can help you sort of deliver those solutions. Coke. All right, cheers. So then we have flexibility and choice with the platform and the service. So you're able to do a lot of things very differently. So if you have a big enterprise customer and you want to have a dedicated set of clusters running at all times, so it's ready to execute work, you can do that. If you want to have individual customers and you want to burst up and down based on things like queue depth or when your business needs, you can do that as well. So you have a lot of flexibility with what you want to do. You can either do things like Windows or Linux, so you can run your workloads on Linux or Windows on the server side, and then provide that as sort of a very broad solution to your users. They could be using anywhere from a desktop to a web portal, but the service exactly is running in Azure and it's running on Linux or Windows. And then we're offering sort of parallel compute on a large scale in Azure. Things like scheduling a service, orchestrating VMs, orchestrating jobs, making sure all that optimization is done, is handled underneath the covers by us. And so you don't have to worry about it. You just manage your workloads in your application. And you're essentially essentially cloud enabling your application. You're not having to go and rewrite your application or algorithm to run on the cloud. You're essentially giving us your executables, we're wrapping it up, and then executing it in the cloud. So it gets you to market a lot quicker as well. And so, let's talk about this in terms of sort of evolution and how we're seeing organizations and enterprises sort of move from on-premise onto the cloud and how they're kind of making that transition. First we have the on-premise sort of cluster scenario where you're an enterprise or an ISV and you've got your on-premise clusters and you're essentially bound by the number of cores or machines you have on-prem. You might be using Windows or Linux, but you might be also using an open source job scheduling service to orchestrate your VMs or your jobs. And again, you're limited by the ability to the amount of machines you have on there, and if you needed to scale out, there's no option but to go out and buy more hardware. And then we have the hybrid scenario. So if you have a deployment of a private cloud in-house and you needed to extend your capability because your utilization is running high, you'd probably want to burst out to Azure. So you'd probably have a deployment, sort of automated deployment where your utilization is running high, more jobs are coming in, more workloads need to be processed. Then there's a bunch of scripts or something that then go out and deploy those VMs in Azure, then deploy your application on top of that, and then finally execute the job. And then you run those workloads, you spin it all down, and then you only pay for what you use for that extended capacity. And then we move on to IaaS clusters. So you completely move your on-prem clusters into the cloud, and you can essentially sort of configure them to your liking, and you can use things like scripts and images and things to deploy these clusters and move entirely in the cloud. But it's still a manual process. You still have to set these machines up, make sure the application's on there, make sure all the dependencies are there. So there's still a lot of work, but at least you're not managing infrastructure, right? So we manage it on your behalf, so things like updates, patches. And then finally, we get to sort of the full SaaS type solution, which is Azure Batch. It's essentially a cloud-enabled job scheduling service, and essentially allows you to bring your application to us, and we take care of everything underneath the covers. So things like data movement and management, job management, user management. So everything is sort of underneath the covers. You only care about your application and your workload, and that's what you code to. And so kind of let's talk about, what it takes to build a service, right? So you might want to move to the cloud, or you might want to move on to Azure for your workloads in your application, but you probably want to design a solution on top of Azure. And so let's see what it really takes to build that type of solution and what are the things you need to consider before you do that. First you've got the hardware, so you could go from commodity hardware all the way up to sort of HPC type clusters, maybe the new A8s and A9s. And then you have to select, do you want to scale up your VMs, or do you want to use, PaaS machines? Do you want to do Windows, or do you want to do Linux? So those are sort of the decisions you'll have to make. And then after that, there's a host of other stuff that you have to build on top. there's a lot of things that you have to do to actually get value out of your application, right? So before you can actually deliver your application to your customers, you want to make sure that your service is stable, highly available, highly reliable. And so things like, installing applications on your VM. How do you make sure all your application executables and any dependencies are already on the VM by the time your task gets onto that VM to execute? How do you make sure something needs to be smart enough to grab your job, queue it, and then split it up into pieces and then distribute it amongst VMs? So something needs to be smart enough to do all of that. Then again, your service needs to be smart enough to make sure that it scales up and scales down at the right time. Maybe it's metrics that you've provided, or maybe it's things like standard metrics like job, queue job depth, or maybe something like timing, for example. And then you have the other part of side of things where you actually have to manage those VMs. Who does that? Is it something that's manual, or is it something that's more of an automated solution, or with a bunch of scripts? So who manages the patching? Who manages restarts? Who makes sure those VMs are running at all times at the right fashion? And then we have users in the cloud. How do you manage all these users? So maybe you're an organization, you have a bunch of different divisions. You have users that use a certain type of application. How do you make sure that that application is being used by the right person, or one person can't access somebody else's jobs or outputs? So how do you manage authentication in the cloud? Then you have data transfer, which is a pretty big one, actually. So how do you make sure your data is at the right place at the right time? You want to make sure your input files are persisted, your output files are persisted, so any outputs that are produced need to be there at the right time so you can access them. Between VM storage and persistent storage, and how that movement kind of happens. So all that needs to be built into the service. And then finally, you have error states. What happens when things go wrong? Who manages that? Is that someone behind a computer, or is that something of an automated fashion? How do you make sure that the user hasn't made a mistake, or how do you make sure that the VM is actually the thing that's causing the problem, or the service is the one that's causing the problem? What happens if a VM is frozen? What happens with the job that's running on top of it? The service needs to be smart enough to grab that job, re-queue it, and then re-execute it on a new VM. So all these things have to be taken into consideration. And this is a lot of work. So this is a lot of work to build all of this into a service and then put your application on top and make sure it's running good. So you can't even get to your application until you build all this stuff into your service. And so let me just show you, before I sort of dig deeper into what the service is and what it really offers, let me actually show you what a actual workload looks like running on Azure Batch, so to sort of give you an idea. And so this is a new capability that we're showing today. It's Linux workloads on Linux VMs on Batch. This is something we haven't had before. So there we go. So I've got a command line opened up, and so what I'm going to be doing is running an application called NAMD, and it's basically a parallel and distributed molecular dynamics package, and it's released by University of Illinois, and it's pretty widely used in academia and industry today. So what I'm going to be doing is actually submitting a job here from within my Windows machine. So here I'm submitting a job on 16 machines, so 16 Linux VMs that are running in the cloud, running Ubuntu 64-bit. And so what this is actually doing is it's taking my job, it's taking my input files, it's splitting it up into different tasks, and it's submitting each of those tasks to a REST API. And so there we go. So the actual script's now run. So I've submitted my job. And then what I'm going to do is I'm going to go into a Linux VM. So this is the master node that's actually running in Azure right now. And this is the VM that's going to be running my executable. So this is my NAMD package. It's actually on this VM and all the other VMs that are going to be running there. And so here what I'm showing is essentially a process viewer for Linux. And so up the top, you can see that it's the process viewer for the master node. And then the bottom two are the process viewers for the child nodes. And so this is going to show you that the cores are actually doing some work. And so what we're going to do is we're going to tail the output that's going to be produced. I see something as array. So actually it might be the Wi-Fi that's screwing up, but let me re-submit the job. Didn't work out. But actually this is a heat map as well, so you can see there's the machines are actually doing something, but it seems like my output's not getting produced. So hopefully a job should pop up. So we'll have to probably come back to that. But it looks like the machines are doing something, but they're not actually submitting. So essentially what's supposed to happen here is it's supposed to produce an output, just a standard output from the actual command line, and it will show you things like, so in this case, the NAM will produce a basically average number of steps per 500 steps. And so it will produce the timing, and so these cores are supposed to show you basically work that's getting produced. So we'll come back to that at the end. I'll show you another demo, and we'll re-go through that. Which one is that? Seems like I've lost my connection here. Yeah. So do we have the tech guy here? Technology. So essentially what's supposed to happen is when you submit a job to the REST API, it's going to take that job, queue it up, split it up into tasks, and each of those tasks are going to get distributed by the Azure Batch service into all those VMs, and then it's going to produce outputs, re-upload them into blob storage, and then provide you the link to the output. So it's a very sort of end-to-end workflow.
Right.
Yep.
How new is this? The reason why I ask is because I went through some training in the fall.
Yeah.
Microsoft Research to do some basic batch processing.
Sure.
And we had to go through a lot of
Yes.
admin steps.
Yes.
And I was in a class with a lot of researchers, and they just didn't get it.
Right.
And I actually don't get what they do, so it's good that we were in the same class.
Yeah, I mean, this is what we're seeing is, right, we have a lot of customers, not just internal, but external as well, that are sort of having to build out that entire, sort of that slide that I showed where, all that stuff needs to be built out. You can get an end-to-end workflow running, but it's not really reliable up until you have, all that stuff built out. And so that's what we're trying to do. But this is new, yes. So we released last year in October in public preview. And so we're going to be having general availability later this year with a few customers. So it's pretty exciting. So you can essentially just take your workload and put it on top of batch, and it just works.
That's fantastic.
Yes.
I was faced with the possibility of having to build this for them. We were getting Microsoft Azure research grants, and the resources weren't being utilized because people were just having difficulty spinning up their environment first to even do high performance computing.
Yeah.
So they're local levels.
Yeah. So I mean that's that's exactly what we're trying to solve. Yeah. So it seems like we have that back. All right. So again, I recapped already, but essentially what we're doing is you can run Linux and Windows workloads. Now Linux availability on batch is going to be later this year. So do look out for that. And alongside that capability, we're going to offer also you to be able to spin up your IaaS VM images as well. So if you have a requirement to have your own VM image that's going to have maybe pre-installed applications or tools, you can actually have that image and then scale it out for your workload. So you can provide us an image, and then we'll scale it out to massive scale for your workloads. And again, we can take care of the scale. So you can have a requirement for 10 cores or 10,000 cores. It doesn't matter. So that's kind of the abstraction that we provide. So at its depth, at its core, Azure Batch is a cloud scale scheduling system for your VMs and your jobs. You can scale from anywhere from tens, hundreds, thousands of VMs, and it does it in a very reliable fashion. So it makes sure that it does, so you do get your cores that you've asked for. Again, you can take your pipeline, so however complicated your pipeline is, so maybe you're doing a bunch of processing, then submitting it to another API for some processing, you get the outputs back. So whatever the pipeline is, you can essentially take it and put it on top of Azure Batch. We're not giving you a set of tools and a bunch of APIs for you to cobble up together and build it yourself. We're actually giving you an abstracted layer, and you just essentially put your workload on top. Again, we give you tools to manage and monitor all this stuff. So we give you a portal experience that you're going to be able to manage your jobs, your users, your billing, your quotas, everything like that. You can manage your resources in whatever fashion that you want and whatever business needs you have. So if you have a bunch of customers that need to be billed separately on a per job basis, you can do that because you can have dynamic VM spin up and spin down. Or if you have bigger enterprise customers and you always need to have those machines up and running, you can have that as well. And then we provide analytics on top of this as well. So these analytics will give you sort of insights into trends, essentially what your users are doing, how they're using your application, how are they using your jobs, how they're submitting, how long are their jobs taking. And you can essentially use this to charge back to your customers. So you can use this information to charge your customers based on a usage model. So this is quite important. So you can provide sort of an end-to-end solution, SaaS solution. And so, I mentioned, quite a few sort of capabilities before, and those are sort of the motivations. And the biggest motivation is, the rich client end-to-end experience. Your value is your business value is your application, your algorithms, your outputs. It's not managing infrastructure. That's not what your users pay you for. So, we provide that abstracted layer, and you just put us underneath you. And then again, you don't need expensive rewrites for your algorithm or your application. You can just put it on top here. You can tell us when to execute, how much to execute, so you can sort of queue things up and sort of basically build a schedule as to how you want to schedule your work. And then again, you can get insights into your application. It's sort of getting away from that licensing model where you have a license you sell, and then customer goes and uses your application. You have no insight into how they're using your application, how much they're using your application, and perhaps this is a solution that can sort of help you capitalize long-term on your customers, because you can then look at their usage. You can sort of build trends from that and actually manage your users in the cloud. Again, I showed this slide before, and it's a really important slide because a lot of people don't realize how much work it is to actually build a service on Azure that's completely end-to-end. So there's a lot of things that need to happen, and essentially Azure Batch will replace all of that. So it will allow you to do application lifecycle. So if you have multiple applications, multiple workloads, you have different versions of your applications, we allow you to manage all of that in the cloud. You have data movement, so inputs and outputs and movement between your VMs and your persistent storage. So we make sure the right things are at the right place at the right time. User management, so if you have a bunch of users or a bunch of divisions, we make sure that people have the right policies and people have access to the right workloads and jobs and outputs. Authentication, quotas, and budgets. So, a lot of things that sort of worry people about the cloud is, hey, I can use the cloud, but then what if my costs balloon, right? So you can actually manage that by actually having control of those resources. So you can say, you can use 1,000 cores, you can use 2,000 for this particular application. So you can have a very sort of customized feel to that. And then the end-to-end client plugin, right? So your users are the ones that are using your application at the end of the day. And so you want to make sure that you provide a very end-to-end workflow and it's very easy for them. And then there's the core of the service, which is the actual scheduling and the optimization and sort of the orchestration of your VMs and your tasks and your jobs. So, what does a workflow look like? So imagine you're an organization and you've taken your app or your workload and you've actually enabled it to run on batch. What does it look like? So maybe you have an app, maybe it's a desktop cluster application, maybe it's an HPC app running on a desktop, or maybe it's a web portal, maybe it could even be a script running as part of a headless service. And so what that is doing is it's talking to our batch API. It's going to go and submit a job. And with that job, there's going to be location to the input files, whether they're on the cloud or on your hard drive. So what we're going to do is we're then going to take that submission of that job. We're going to take those input files, upload them to blob storage. We're then going to take your job, put it onto a queue, pick it off the queue, split it up into different tasks. And you provide us sort of the logic to split those tasks up. So you can tell us how you want to split your job up, because every application is different, so every workload is different, so you can tell us how you want to split that job. And so once we have the tasks, we then take those tasks and schedule them on VMs. And those VMs already have your dependencies present on top of them once your task gets to those VMs. So if you have executables or third-party libraries or whatever else that you need for your task to execute, we'll have them on the VM before the task gets to the VM. And then so once the task is completed and it produces some metadata or outputs, you tell us what outputs you need, and we'll upload them back up to blob storage and then clean the machine up again. And then so all of this workflow you can manage via the portal. So you can look at things like job history. So you can look at your entire job history. You can look at it via application, via workload. You can sort of filter it via users, perhaps. And then you can look at things like status. So what's the status of your job? Is it completed? Is it errored? Is it canceled? Perhaps. You can look at progress. So how far ahead is my job? So if you have a long-running job, you can sort of keep a track. You can then go into details of a job. You can go into tasks, individual tasks, and sort of download individual task outputs as they complete. And then you can look at performance telemetry as well. So if you're running on, for example, extra large machines with 8 cores, and you can see that your CPU is hitting sort of 90 to 100% high, you can then switch those machines up. So we give you the performance telemetry to sort of optimize your workflow. And then again, you get the usage reporting, right? So if you have a bunch of users using the service, you can then look at how your users are using, and then you can sort of charge back based on usage. Again, we give you application management from within the portal as well. So if you have a bunch of versions of your application and you want to make sure the right one is being installed in the VM once the job is completed, we help you manage that through the portal as well. And so sort of give you a demo of sort of demonstrate this end-to-end vision and capability. I'm going to show you a commercial application. It's called Autodesk Maya. I'm not sure if anyone is familiar with Autodesk Maya. Big company and a big application. So it's used in media entertainment quite a bit of time. So any latest movie that you've seen, all the visual effects, most likely done in Autodesk Maya. And so what we've done is we've produced a plugin, a native plugin for this app. So hopefully. Okay, so we can see that this is Autodesk Maya 2015, and you can see I've got a bunch of balloons. Those are 3D models, and so I'm producing an animation. So I'm an artist, so I'm the user of that Autodesk Maya product. So imagine if you were a ISV providing your application as a service. You're providing that application as part of the native experience for your users. So users have no idea there's this thing called Azure running in the background. They just want to submit their job. They just want to get their workload done and then have the outputs and pay for what they use. So you provide this experience natively within the application. So here the plugin launches. It authenticates me automatically because it knows I have access to that service and I can submit those jobs. So I can see things like pool settings. So up top, I can actually manage how I want to submit my job. So if I want to just submit my job and not care about the infrastructure, I can submit a job, we'll spin up the machines, execute your work, and then spin it back down. And then you can even reference an existing pool. So if you have a pool of machines that are running at all times, and you want to reference that pool of machines, you can do that within here as well. And then finally, I might want to say, I do want you to spin up the machines, but I want to keep them up. So I can keep submitting jobs to it. So you can do that as well. And then you can select a bunch of instances. So you can select anywhere from whatever amount of instances that you want. And then you can select settings. So down here, I can select settings like job name. I can give it a frame range. So for example, if this is an animation, maybe I want to render 10 seconds of it. So I can give it a range of 1 to 10. And it'll split it up in terms of, so in this case, the job will actually split it up into different frames, and each frame is a task or a piece of work that needs to be done. And here I've got my assets. So in the digital community, assets means files, basically. So in this case, you can think of it as anything and everything that you require with your job that needs to be in blob storage. So if you require extra third-party metadata that needs to be uploaded, you can select files or folders or whatever else that you need to upload alongside your job. And so the plugin will take care of that. It'll package it up, and it'll make sure that your stuff is in blob storage and it's automatically downloaded to the VM when you execute your job. And then here we have a sets of pools. So here I can see I've got actually a pool running here, and it's 50 VMs, and it's persisted. So I'm not sure if you can see. Let me just... So I've got a provisioned VM, pool of VMs. So I've got 50 machines running there. So that's 400 cores. And I can resize the pool anytime I want. So if I submit a job and it requires 50 VMs, great. I've got a pool of machines running there. But if I require a production job, maybe it requires 10,000 cores, I can resize this pool to whatever I need, up and down, on an on-demand basis. And then finally, we've added sort of the capability to have job details as well. So here I can see there's a job that's actually in progress. So this is a job that I just submitted previously, just before the session, and we can see it's in progress. It doesn't have a preview yet. It's running on those pools. I can see when it's submitted, what pool it's submitted to, so you can keep a track of that. And then here, I can show you a job that's already previously completed. I can see a preview of that job, what that render looks like. We can see that it's complete, it's 100% complete, and then it's run on 500 tasks. So I've actually scaled this across and then scaled it back down. And then again, I can download my output right from here. So this is a link to your output that's sitting in blob storage. Is there any questions on this here up until now? Okay, so the question was, are there any other plugins for any Autodesk products? Is that right? Yeah, so at the moment, we've actually released a plugin for Blender, which is an open source 3D rendering program. You can go download it, and we've open sourced sort of the plugin and the library that it's built upon. This one is the one that we're currently working on, which is Maya. And we'll be working on a couple of other rendering programs like Arnold and V-Ray and things like that. But we're happy to sort of take feedback and see if there's any opportunities to look at other things. But essentially, this plugin is built in Python, and it's built on top of our Python client library, which is what we offer as well. So the Python library is available right now. You can download it. It's open source. And so, Python is very flexible and very portable. So we've built that on top of this. Anything else? Yeah?
Yeah, so if you, let's see, with regards to like MATLAB or
Yep.
Revolution, R,
Yep.
that sort of thing, or if somebody just has their own process or something like that, I mean, how difficult would it be to customize the, I guess the plugin, the Java, the Python, in order to put this, I guess you don't have something for MATLAB.
Right. So the question is, how hard is it to sort of build a plugin, and how hard is it sort of extensible, right? So yeah, I mean, again, MATLAB, we're sort of, we're open to sort of looking at that. We've actually released a blog post on how you can actually scale our workloads on Azure Batch. So I'd encourage you to go on the Azure blog and have a look at that. So R is an open source statistical language, and you can scale out your sort of statistical analysis on Batch. So you can absolutely do that. Now this is an end-to-end experience, right? So this is a client experience. So this is up to the enterprise or the ISV to build on top of the API. Now this is sort of a really good example of us to show you, but you can absolutely, this plugin can be a web portal, for example. So this plugin can be a web portal, it could be a script, it could be even a separate application altogether. But this is a really good way of sort of introducing this kind of service to your end users, where they don't actually have to learn anything new, because it's within your application itself, and you can just go and click a button, and all your jobs are done. But you can absolutely, yes, put in MATLAB. You can develop because it's just a REST API, right? So.
Okay.
So in this case, you have the Maya application. You have an instance of this application running on each of the VMs. Is that correct?
Yes. So the question is, we have application running on each VM. Yes.
And
Yeah.
then, there is no animation. You're trying to render this image. Am I right? Is the source of light moving, or is it?
Right. Yes.
So
Yes.
What is changing here? That because you can probably render it within one of
Sure.
a few VMs. What is making it intensive in this situation?
All right, in this situation, so this, I mean, for example, if I was to render, so this is actually an animation. So what this is doing is a very simple benchmark that Maya provides on their website. And so what it's doing is basically producing extra balloons in that scene. But what it's doing is it's producing more and more 3D models, right? So it's getting harder and harder to produce. And so exactly what happens is, on the bottom, you can see sort of a timeline, right? And so that timeline refers to a frame. And so every time I say I want to render from 1 to 100, it has to go and process that frame and then produce me essentially assets or input files for each one of those frames, because the scene has changed every frame that it's moving. And so we actually take all those scenes and then put them up to the cloud. And so some of these scenes could be terabytes long, right? But then also some of these scenes could be very complex, right? So if there's lighting, shading, textures, and even if you produce this in HD, for example, if you produce it in 1080p, it could just take forever. So the job that I ran on 500 frames previously, this one here, took about 10 to 15 minutes to render, and it was a 7-second animation. But if I was to render this on my PC here, which is a i7 dual-core PC, it would have taken days, if not months, to render. And what we're saying is, you could submit a job and then monitor your job from within a tablet or a phone while you're on the move, or you can get your application free so you can keep working on that workload. You don't have to stop because your machine is chuggered down by that workload that's working.
So some of these are running in parallel. So some of the images are getting processed
Yes.
faster than the other, but there
Yes.
is a continuity. Am I right?
Yes.
Sequence. How do
Yes.
you manage that? How does
Yeah, so the service actually does it. So the service actually, service has the logic to say, okay, you're running these tasks, I'm going to submit these tasks because they're individual, right? They're individual pieces of work. And while the task is running, while the job is running, as those tasks complete, you can keep downloading those outputs. So individual frames. But then at the end, I've got a processing task at the end to say, look, when all my tasks are complete, take all the outputs and put it into a movie. So I can have sort of like a post-processing task to say, merge all my task outputs together and provide it to me as a movie so I don't have to do it. So I can come back tomorrow and be like, oh great, my render's done, I can just download it. Yeah.
How do you handle
Sure. Yeah, so the question is how do we handle licensing? That's a very interesting question. So it depends, right? So in the rendering solution or any other solution for that matter, each ISV or each enterprise has their own sort of licensing solution, right? Some are using FlexLM, some are using something else. Now in this case, we could be running a IaaS machine that's actually got the license server, and we maybe have a limited number of licenses there, so you're kind of constrained by that capability of launching how many machines. So if I've got 500 licenses, I can only scale out to 500 machines. But I think the change that we're seeing talking to customers is that they're actually moving away from that, because a license doesn't give them the capability to look into what the user are actually doing with their application. They want to be into more sort of the usage model, where they're actually charging their users for per job essentially. So that's sort of the common feature that we're seeing, is they're trying to move away from selling single licenses on a desktop to more sort of charging their users based on usage. Hopefully this pops back up. No. There we go. All right, so just a quick recap. Really, really rich client experiences. So this one is actually built on top of the Python client library. It's open source. You can go download it, test it out. The service can run either on Linux or Windows. Now Maya actually runs on Linux, Windows, or Mac. So in the back end, the actual application could be running wherever, but then on the front end, your user could be using Mac OS, could be using a tablet, could be using whatever. So it doesn't matter to user where the service is actually running. So this is a great sort of end-to-end experience. And essentially, you're providing a service as a solution. So that's kind of where we're heading at. And so this is a customer that's currently built on top of Azure Batch. So they've actually got an application called Risk Agility FM, which is traditionally sort of a cluster application, and it's essentially designed for actuaries to develop and run models to manage risk and solvency, and they're basically primarily based in life insurance industry. And so one of the biggest motivations for these guys is that it opens up a host of new customers to actually manage their grid clusters. So what that means is, those customers, or smaller individual customers, don't actually have the capital expenditure to go out and buy new machines or build out a whole new data center. They can actually use Towers Watson's Risk Agility FM as a service. So it opens up a host of new customers for them. And then again, they're concentrating on their business value. They're not having to spend months and years building a service. They're concentrating on what they provide best, which is the modeling, not managing infrastructure. So that's really, really important. And actually, one other thing I'd like to mention is that Towers Watson is actually one of those customers that actually gone through the evolution that I mentioned before. So they were an on-premise customer where they had on-premise clusters, and then they sort of moved to the hybrid scenario where they were actually fishing out workloads using HPC Pack into Azure, and then now they're sort of transitioning into that full SaaS type model. And the second use case here we have is something you might have been already familiar with, is Azure Media Services. They're actually built on top of Azure Batch, and then they provide a host of services such as transcoding, encoding, on-demand streaming. They also provide services such as speech-to-text algorithms and indexing, media indexing. And so one of their motivations is they're actually providing a fully SaaS solution to their customers. The thing here is that they're not managing infrastructure, but they do want lower level control of their VMs because they want to make sure the things that are on the VMs are correct for each use case, whether it's encoding or maybe indexing, so they can provide a host of different use cases. But then they can also have different use cases for their different types of customers. So maybe they have big media and entertainment customers that are enterprises that want the ability to have access to dedicated machines at all times. They can still provide that by having a pool of machines that are running at all times. But then they can have these individual customers like students or individual artists that can go and use media services on an on-demand basis. They just submit their job, it spins up, executes work, and spins back down. And then sort of the extensibility is the other thing that I wanted to mention here. You know, we have a lot of customers that are sort of currently sort of trying this out, where you know you might have a job that's doing some analysis, that's producing some results, but then you might want to take that result and put it into a Hadoop job. So they're then talking to the HG Insight service and producing that output. Maybe you want to produce some predictive analytics. So maybe you want to take your outputs after Azure Batch and then put them into machine learning. So there's a lot of other services that will help you sort of increase that value of your business and then sort of allow you to extend the capabilities and then offer that as a service. And so, you know, just to sort of summarize some of the main points that I've been trying to hit are, you know, as you grow, we grow. So if you have a model where you're running 24/7, whether it's 10 cores or 10,000 cores, we can enable that. If you have sort of a up and down sort of hockey stick, or you know you're just unpredictable bursting, we can cater for that. And then you don't have to entirely move onto cloud. You can sort of take baby steps, right? So you can have an on-premise cluster, but then only burst out when you need to. So you can still keep use of that cluster on-premise, but then burst out and use Azure for whenever you need it. So if your utilization is running high, you can then go out. And again, you know, this point is very important. You saw that slide and how hard it is to build a solution. You know, we want you to concentrate on your applications and your value, and let us, you know, deal with sort of the crux and the lower level stuff. And so you provide, you know, your applications as a service, not managed infrastructure. And again, you can run true HPC workloads on this service. So you can use things like A8s and A9s. You can use MPI. You can use A8s, A9s for InfiniBand, low latency hardware. And then you can execute these workloads both in Linux and Windows. And again, Linux is going to be available later this year with IaaS, so do look out for those announcements. And then again, you pay for what you use. You're not having a set of machines that are sitting there doing nothing, costing you money, making sure you have to maintain them, making sure they're updated. You essentially just pay for what you use with Azure Batch. And so, I had my email up there, but please feel free to come up and grab my email. I'd love to hear some feedback in terms of, you know, if your sort of model and your application is very suited to this model. And maybe if you just maybe want to try it out or learn a little bit more as to how the internals work, I'm happy to sort of share that information. And then, yeah, please go and evaluate. Any other questions? Yep.
Is there other patterns for actually developing software that matches well with multiple execution styles that can scale, for instance, like in computational mechanics or fluid mechanics you mentioned? Are there any kind of patterns that you can recommend in terms of dividing up the actual...
Dividing up work?
Yeah, because for instance, this Maya application runs as a monolithic.
Yes.
Same thing.
Yes.
But you can probably even divide that.
Well, I mean, you can even use things like MPI applications, right? So MPI is not currently supported, but we are getting to that point later this year. So you will have the ability to. So I think it depends on application to application, right? So you know, with transcoding, for example, you can't split up a movie into different pieces, so you have to encode it, right? So maybe it's not about the actual job, but maybe it's, you know, spreading out those jobs over a large amount of instances, right? So maybe you have a set of clusters and you're submitting a job after the other, but maybe this will enable you to submit lots of jobs in parallel. Maybe it's not something that you'll be able to do within the job itself, but it's something that you'll be able to utilize, you know, jobs for, is to sort of spread that out horizontally. But yeah, I mean, it really depends, right? So it depends from application to application. So, you know, in terms of, we have DNA sequencing as well. So if you're sequencing genomes, you can have multiple genomes. So it really is up to the ISV to sort of determine how they want to run this, right? But then we also have customers that are not really high performance, but they're just trying to offload their workflow and pipeline. So, you know, they have something like, they make a backup, and then they go run some custom code on it, and then they have those results put into a SQL Server, and then they run some analytics on top of it using machine learning. Now, that's not really big compute, or it's not compute intensive, but this service allows them to do that workflow without writing sort of the crux of the infrastructure. They don't have to manage data movement. They don't have to manage kind of the VM orchestration. We can just encompass it within a task or a stage. So we can allow things for something like, hey, I want to run task 1 to 10, and then once those are complete, I'm going to take the outputs of that and then run task 11 to 20, maybe. So we can have dependencies within those tasks. So it really depends on how you want to manage your solution, but then, we provide analytics so you can sort of improve upon that. Yeah.
So I guess extending on what he asked, that demo that you showed earlier with that, I guess it was DNA sequencing,
That was, so molecular dynamics, yeah.
Right,
yeah.
so how were those broken up? Was it effectively 16 different input files, or is there like a single orchestrator that was built into the app that?
Yes. So it was it's actually an APO A1 benchmark with standard variables. You can have a look at it on the University of Illinois website, and essentially it's a bunch of steps that you run. So we were running 500 steps, and each of those NAMD executables were on those Linux VMs executing that task, and they were split up. They were predetermined, so we wanted to split it up based on certain factors, and so we split it up in chunks of work. Yeah.
Okay, so each one of them basically had a specific.
Yes.
Okay, so
Yeah.
when you submitted, and was that determined when you submitted the job? Or
Yes, so that's into the submission code. So I'm saying submit my job with 16 instances, and the service on the back end actually has logic to determine how to split it, and that logic is determined by you. So you tell us how you want to split it, and we've already predetermined that. Yeah.
Right, so it wasn't built into the actual
Yeah.
EXE itself.
So it's actually built into the service. So that client was actually talking to that batch API, and behind that batch API, when you submit a job, it has the logic that you put in there. However else you want to divide it. Yeah.
How would, so, let's say you have like this group of maybe 50 people and they all want to use this. I mean, can they use something like this, like a one scheduler, or would you have to sort of build some dividers there so that they don't?
So are you talking about in terms of load, or how?
I'm talking about, so some might have small jobs, some might have big jobs. I mean, can somebody share an environment? Let's say 50
Sure.
people.
Absolutely. So yeah, that's what I was mentioning before, right? So if you have a enterprise customer and they do want to run all their VMs standing up at all times, but they do have multiple users, so you can allow sort of a sets of users to say, look, I want person A, B, and C to reuse these resources because maybe you want to use A8s and A9s, which are more expensive for a certain amount of workload. But then you might have these sort of artists or individual customers that don't really have the money to use these big machines, but they just want to test it out. So you can have sort of individual dynamic. But yes, you can have users share resources, and sort of the admin, who's the sort of the orchestrator, will manage how those resources are used. And then you can set things like quotas. Look, person A can't use more than 1,000 cores, right? So the job goes on pause until the admin sort of approves it. Yeah. Yeah. Yep.
Are there best practices for moving large amounts of data from your corporate network to storage?
Sure. Yeah. I mean, there's a bunch of documentation on that. For example, we've had use cases where some of these rendering workloads are sort of commercial workloads that are rendering movies, for example, and that data could be in the terabytes, right? So people have done things like integrate Aspera, for example, or do ExpressRoute, or a bunch of other things. So yes, there are best practices, and we have customers that might want to use sort of scalable storage. So maybe they're using Lustre for their storage. But that's absolutely possible. So there's many different ways. Yeah, and it also depends. I mean, in this case, for example, the rendering workload that I showed you. So the service has the capability to determine how. If the files are changed, right? So if you're working on your model and you upload it for the first time, obviously it's going to upload the whole chunk. But then the next time you can optimize and say, hey, look, I haven't made changes to half of these files, so only upload the diff, right? So you can absolutely optimize on top of that. Yeah. Anything else?
Yeah,
Yep.
so this is more of a, I guess, conceptual question. So, I mean, it's basically you partition and you merge, right? It has
Yes.
2 steps, which is kind of map reduce, right?
Yes.
So, I guess I'm trying to figure out, where batch fits and where Hadoop fits, especially knowing that we're about to get a preview of on-demand, HDFS where do you do one, where do you do the other?
I guess the differentiator is, you know, the SG Insight is very sort of specific use case, right? It's running Hadoop jobs, Hive, and all that sort of stuff.
Right.
We're trying to create a service that's more generalized, right? So, for example, Hadoop jobs or SG Insight could actually run on top of Batch as well. So, you know, they don't have to actually manage their clusters, which is what they're sort of offering at the moment. But we're trying to produce a generalized sort of service which can fit into whatever use case. We're just saying if you need access to hundreds and thousands of machines in a very reliable fashion, you use Azure Batch. And it doesn't matter what the workload is. Could be Hadoop, could be rendering, could be Fluid Dynamics, could be MATLAB, could be whatever. And you just kind of put it on top. So we've kind of generalized what they've done a little bit, but kind of made it a bit more reliable, accessible, and you know, you're not sort of talking to 5 different APIs. You're not talking to storage API and management API. You know, you don't have to be an Azure expert in this case. It's just a generalized API, submit job, cancel job, deploy application.
So it could, I mean, be used for big data workloads.
Yes, absolutely, absolutely.
Does it, you know, does it spin up faster? I mean, the node's already there, right? So I don't have to.
Well, yeah. So I mean, there's always that spin up time, right? But when you sort of so we do, there are some smarts that we have that essentially let you sort of scale up to a large amount, right? So if you were to go and go on the Azure portal and launch 10,000 cores, you're most likely not going to get them, or you know, half of those deployments will fail. We have some smarts in there that actually allow you to scale up that amount. Now, you know, all those machines might not come up in a jiffy, but you know, you might get them. You know, you might get 90% of those machines in 10 minutes, and then sort of the last 10% over the course of time.
Okay. What if you just need to say, I don't know, 50 for 5 minutes?
Sure, sure.
Is that pretty fast? Or
Yeah. I mean,
usually already kind of provisioned and available?
yeah, and I mean, we have customers that are actually doing some smarts around. You know, they're running sort of like a sort of a base level of machines, so they might be running like 10 machines at all times, right? Because once the job comes in, they want part of the job to start running, but then they're happy to wait for the other sets of, you know, 40 machines that may be coming up at a later stage. So you can have your, you know, sort of job process quickly or start processing, and then those machines, as those machines are coming up, they're picking those tasks off the queue and then processing them. But yeah, it's fairly quick, but it depends. I mean, it depends on, you know, what kind of machines you're asking for in what region, what the availability is like. So, you know, if you're asking for things like A8s and A9s, which are the sort of the HPC hardware, they might be in more demand. So it depends on a lot of factors, but we offer, you know, scaling up very reliably. Yeah.
What, from a what you pay for standpoint, you're paying for the compute if you don't release them at the end, right? You're still on the clock.
Yes,
Right?
yes. So you start paying from the time that machine pops up until the time that it spins down. Yes. Yeah. So I mean, it depends. I mean, for a license server, it could be running all day, every day, right? So you're paying for that machine. So you might want to have something like a smaller machine running that license server, but the jobs could be just dynamic. Yeah. Yep.
Excuse me, is this all based off of the normal Azure pricing scale, you know, for VMs, you know, A2s?
Yeah, we haven't announced sort of, you know, we're still in preview at the moment, and so closer to sort of GA timeframe, we'll announce some pricing. But at the moment, yes, it is based on sort of the normal Azure pricing. I think it might even be discounted, but I can check on that.
Yeah, it'd be nice to know if you know, if there's a pricing offer where if you submit jobs off hours or things like that, you know, that where that compute's not quite as much in demand that you can price break or something
Yep.
like that.
Yep. Yeah. So you could do smarter things there, and there's probably things that we're going to be sort of announcing at a later stage that will sort of.
Right, there's pricing for compute, and then there's also, I'm assuming, a price for batch.
So at the moment, for the core service, probably not. But you know, as we sort of offer more features like sort of the end-to-end experience that I showed about, you know, the analytics, the user management, sort of, you know, you can federate users from an organization using AAD and things like that, right? And then just put those users in the cloud and manage them. So for some of those services, we haven't released pricing, but you know, we'll closer to time we'll sort of release that information. Yeah.
You mentioned there's an API front end for all of this, it's all RESTful. So I think for my case, I would just abandon what we were doing before, spinning up the really don't want to have to do, some kind of giant PowerShell, scripting automation through the REST API to get MATLAB to run for these people. I actually would be a step forward, but if there's going to be some plugin available soon, I might as well not bother.
Yeah, I mean, we're seeing people sort of still sort of wrestle with the idea of how they want to provide these services. We have customers that do like the idea of that end-to-end, but then don't want to dedicate time in actually building that stuff out. I think as time moves forward, we are seeing, end users actually question, hey, can I use a remote render farm, for example, in the rendering case? And so it's making companies and organizations have to look at that kind of infrastructure. But we've had a lot of customers that are talking about sort of white labeling this service, right? So essentially, the ISV providing the service is the first level of support. And then if something goes wrong with the service or the infrastructure, Microsoft's kind of behind the scenes, and then the ISV contacts us. So there's kind of that chain that's going around. But what we're seeing is organizations want to own that service. They want to market it themselves. It is their service. They're providing it on top of their application, and they own the customer relationship. And so I think to keep those customers where they are and not lose them, they're starting to sort of divulge into this end-to-end where, hey, the next version of blah 2015 or 2016 is going to come with a button that will allow you to magically, process your job way faster, right? So.
I'm an academia, so that's all people are after. They just want their MATLAB job faster.
That's right.
They
Yeah.
don't care how it happens.
Yeah. I mean, that's the premise of the cloud, right? I mean, that's the premise is, hey, you've got potentially unlimited amounts of compute power. What can you do with it, right? And so, a lot of people are sort of struggling with not just that, but, things like security and, where's my data living, or, how hard is it to actually go and build out a service? Do we have the resources? And so what we're trying to do is, hey, you don't have to go out and, hire Azure experts. This is a abstracted layer of API. You essentially bring us your executable, we'll wrap it, and just run it, right? So here's my executable, here's my input file, go just do it, right?
When is this officially available?
So you can use it right now in public preview, so most of the features that I talked about, and then we'll be announcing a GA release date in the next few months. Yeah. But we do have customers that are running on it already. Azure Media Services is obviously a big one internally, and then we have Towers Watson, that's a global customer. Yeah.
We have a few research grants that are active now from Microsoft Research to be able to leverage
Absolutely.
VMs as part of that grant.
Absolutely.
Great. Okay.
Absolutely, yeah. I mean, we'd love to, connect later and sort of help you figure out because, MATLAB and R seems to be coming up quite a bit, and obviously, we'll look into those things. Yeah.
What are Microsoft competitors doing in terms of this type of fashion?
I think I'm seeing quite a few sort of specialized kind of things. I think Google bought Zinc, a company called Zinc, which is essentially doing similar, but they don't really have that kind of full end-to-end story, and it's basically only for rendering. Then we're seeing a couple of others do things like financial things, but there's nothing out there that's kind of generic. Amazon provides you a bunch of tools and APIs, and you just have to go and build it yourself. So basically every cloud provider is going to provide you, those kind of APIs. But I think, this is kind of one of those services that is going to bring all that together and just provide one API that's abstracted. Now, there's a lot of teams that are rebuilding or reinventing the wheel, and that's why we're trying to sort of make sure that it's, reliable, scalable, because people don't think about those things. They just say, oh, it's just batch processing. I can do that. But then, what happens with those other things like failures and users and management and all of that, right? So that's an important one. So we're focusing on end-to-end, not just processing your work, but actually being able to do something valuable with it and actually having you sort of manage that whole workflow.
So one thing maybe I missed, I was surprised you didn't show us a dashboard that, like maybe the factory and other components.
Sure. I mean, I can show you sort of the preview dashboard. And so, yes, it's work in progress. So we're actually onboarding. We're going to have a new experience in the Ibiza portal, which is the new portal. And so we're going to be showing that off fairly soon. But we do have a preview portal. So we do have a preview portal that will allow you to do the things that I mentioned. So job management, downloading outputs, looking at performance telemetry. So it will allow you to do all those things. So in fact, actually, maybe we'll even bring it up. So I can actually show you what that kind of looks like. Might have to actually sign in with my credentials. Yeah, I might have to actually, I have to sign in with my Corp credentials, so I won't be able to show you, but it's available right now, so you can go have a look at it. Yeah. So once you create a batch account within the Azure portal, you'll be able to click a button that will take you to a portal experience. So that's currently what's available for the preview experience. So, but it does allow you to do everything that I mentioned. Yeah. Yeah.
Should build out a new portal in Visa.
Yeah. So that's why we're not showing it off currently. But you're more than happy to for you to go and try out the preview experience. But essentially, it's a separate portal experience. What we're doing right now is we're integrating that into the current Azure portal. Yeah.
With resource groups and blah, blah, blah.
That's right. Yeah. So, I mean, right now, it's, you'll be able to sort of look at your jobs, look at your status, go through your telemetry, your performance telemetry. You can even look at things like logs. So, whatever your executable produces is then surfaced up to you. You don't actually have to go into the VM, RDP into the VM, try and get the event logs. We surface all the logs to you. So we'll tell you, what your application's actually doing. But then we'll also tell you what your VM is doing. So, maybe your application isn't the one that's incorrect. Maybe it's the VM that's failing. So you can see all of that. But yeah, I mean, feel free to go and try it out. It's pretty cool. Yeah.
Do you have any comments on the Microsoft app? They acquired Revolution Analytics.
Yeah, I mean, I think it's fairly new, so I don't have any insight into that. But yeah, I mean, we're I think. Yeah, I think it just.
There was, if you search Revolution on the.
Yeah, I think it just closed, so we don't have much info about it. But it's very recent. Yeah, but I mean, absolutely. I mean, R has been coming up a lot. It is an open source technology, so you can go and run your scripts on batch if you need to. But we'll actually be we'll be talking with those guys at some point. But yeah. Cool. All right. Thanks, guys.
All right, thank you.